Okay, today we are going to be talking about reference angles, and it's very important that you get this definition memorized, especially a couple of keywords within it. So here it is. Reference angle is a positive acute. I'm going to go back and make that green. A positive acute angle formed by the terminal side, the ending side, the terminal side of an angle in standard position and the x-axis. So you can see the three key words: positive, acute, and x-axis. All right? It's never negative, never greater than 90, and it always comes off the x-axis. Those are the three very, very important things to keep in mind about reference angles. Otherwise, you'll probably get them wrong. So, in quadrant 1, an angle in standard position could look like this. There's theta, an angle in standard position. The reference angle is the positive acute angle. It's inside there. I'm calling RA for reference angle. And I will explain how we're going to use these in a little bit, but let's just see where they are first. So the reference angle is the same as the measure of the angle. The terminal side and the reference angle, they are the same. So the reference angle we'll put in a different color is the same as that angle in standard position. So we say that the reference angle is equal to our angle theta. Quadrant 2, if we take our angle in standard position, it would go like that. There's your angle. Think back to like the very beginning of the chapter where we were just drawing angles in standard position. They always come off the positive side of the x-axis, and we're doing counterclockwise angles. I mentioned that in the notes up at the top here. The reference angle has to be positive acute and off the x-axis. For that to happen, it has to be right here. That's acute, it's going to be positive, and it's coming off the x-axis. So this is the reference angle. Obviously, these are not equal. In quadrant 2, the reference angle is equal to 180 minus the angle. So the reference angle is equal to 180 minus theta. And vice versa, if you were looking for theta, theta would also equal 180 minus the reference angle. In quadrant 3, so let's say we have an angle in standard position. So there's theta. The reference angle has to be positive and acute and come off the x-axis. So there's the reference angle. It's off that x-axis. Never are we going to have it off the y-axis. Here's your x-axis. So the measure of the reference angle can be calculated by taking theta and subtracting 180 from it. If you're looking for what theta is and you know the reference angle, then it's 180 plus the reference angle. quadrant 4. So this angle, standard position, would be like that. So that's theta, 300 degrees or whatever. The reference angle has to come off the x-axis. These angles are in the same location as the reference angles are in the same location as theta was kind of when we did those right triangles in the examples from previous lessons. So if I want the reference angle for quadrant 4, I would take 360 minus theta. If I want the measure of angle theta, I would do 360 minus the reference angle. So the trickiest one is really quadrant 3. Okay, so for examples, find the measure of the reference angle for each angle. So in quadrant 1, if you're at 25, the reference angle is 25. For 250, so if theta is 250, that tells me that I'm in quadrant 3. Remember down here is 270. So I'm in quadrant 3. So in quadrant 3, if I'm looking for the reference angle, I'm going to do theta minus 180. So I'm going to do 250 minus 180. So the reference angle turns out to be 70 degrees. The next one, theta is 305. That's in quadrant 4. So in quadrant 4, if we're looking for the reference angle, in quadrant 4, it's 360 minus theta. So 360 minus 305 puts me at a reference angle of 55. 175 is in quadrant 2, and the reference angle in quadrant 2 is found by doing 180 minus theta, which is 175. So we get a reference angle of 5 degrees. All right, negative 210. This one I think I need to draw something because we haven't talked about a negative angle yet. So I'm going to do a little diagram here. So negative 210 would be in standard position like that. So there's theta equals negative 210. The reference angle is this little piece right here off that x-axis. That's the reference angle. To find that, you need to think about it. I have this as 210. If I want to find that little piece, I'm going to do the reference angle equals 210 minus 180. And that will give me that little piece. And 210 minus 180 is 30. Now notice I did not use negative 210. Negative just tells me a clockwise direction. I'm trying to find a positive acute angle off that x-axis. And negative 340. For negative 340, that would put me into quadrant. Here's negative 270, and here's negative 360. So that would put me right here in quadrant number 1. So there's theta, negative 340. I want this piece right here. This is the reference angle. So the reference angle would be 360 minus 340. I'm not really using the negative. I'm just looking for that positive acute angle, and that turns out to be 20. So down here, find the exact values of sine 150, cosine 150, and tan 150. If this is difficult for you, then draw a picture. I need pictures, so I will probably draw pictures on all of them, like I did on the last two. So for sine of 150, I'm going to set up something that is known as Q, R, and S. Now Q stands for quadrant. R stands for reference angle, as you might have guessed, and S stands for sine. not S-I-N-E, sine, as in all students take classes chemistry or calculus. So I'm going to set up QRS on this, okay? So I'm going to do Q, R, but then they're all going to get their own sign. They're all going to be in the same quadrant, but and the reference angles are going to be the same, but the signs are going to be different. So I am in, when I draw 150, standard angle and standard position, there it is, there's 150. The location of the reference angle is right here. That's the reference angle that I'm looking for. So I'm obviously in quadrant 2 with a reference angle. So I'm in quadrant 2, so my reference angle is 180 minus 150. So my reference angle is 30. Okay, so now I can say that the sign for SINE, the SIGN for SINE, is positive in quadrant 2, but negative for cosine and negative for tan. So what I'm going to do next here is say that the sine of 150 is the same as the sine of 30. The cosine of 150 is the same as negative cos 30, and the tan of 150 is equal to negative tan 30. And then I can figure out the exact values of those. The sine of 30 is 1/2, so that's the answer for that one. The cos of 30 is radical 3 over 2, so it's negative 3 over 2 for that answer. And then negative tan 30 is negative radical 3 over 3. Now, to make some sense of this, you need to go back to in your notes and find a diagram that we kind of skipped that looks like this. I believe yours might be handwritten, though, and might not have the angles. So I'm going to give you a minute to get these angles written down, if they're not already, the 30, 45, 60, 90, 120. All right, and then we're going to talk about filling in some of these pieces. So I'll start talking again in about a minute. Okay, I lied. It's about almost a minute. So let's just talk about this. Let's pretend, we're on the unit circle. This is 1, 0, 0, 1, negative 1, 0, and this is 0, negative 1. So when you're on the unit circle, remember the cosine of your angle is equal to the x-coordinate and your sine is equal to the y-coordinate. So right here, this point right here is the cosine of 30, comma, the sine of 30. So this coordinate could really be written as radical 3 over 2, comma, 1/2. Okay? So this can then happen all the way around. So this one would be the cosine of 45, comma, the sine of 45, which is really radical 2 over 2, comma, radical 2 over 2. And then for 60, it's cosine 60, comma, sine 60. So that coordinate right here is really equal to 1/2, comma, radical 3 over 2. So that's from that chart that should be memorized. And then one more, the cosine of 90, comma, sine of 90 is equal to 0 and 1. I already have that point written, okay? So now let's think about this. If we go into quadrant 2 with an angle of 120, it's at the same exact height as an angle of 60. It's at the same amount over to the left as to the right. So it's the same exact point, except one is negative and the other is positive. So I guess what I'm trying to say to you is that this would be, oops, sorry, hold on. This would be cosine 120 comma sine 120, okay? So the cosine of 120 is the same as the cosine of 60, but it's negative. So we can use 60 degrees as a reference angle. The sine of 120 is exactly equal to the sine of 60 because it's positive, because they're both going up the same amount when you plot the points. If I were to plot this point, it would be, again, the cosine of 135 comma sine of 135. But in degrees, those are the same distances to the left and up as to the right and up to 45 in quadrant 1. So we are really referencing a 45-degree angle. So the cosine of 135 is just negative radical 2 over 2. The sine of 135 is positive radical 2 over 2. And one last one here, we've got the cosine of 150 and the sine of 150, which should reference the cosine and sine of 30 in quadrant 1. They're the same amount to the left and up as you would go to the right and up in quadrant 1. So this coordinate would just be negative of what cosine 30 is, which is radical 3 over 2 comma 1/2. So you can kind of see, you should be able to see how the cosine of 150 equals negative cosine of 30. And that's what we're saying in this example that we did. And we could continue this all the way around. So for this one, it would be this is supposed to be 210 down here. So this could be cosine 210 comma sine 210, which would really reference a 30-degree angle in quadrant 1. So its coordinate is just negative radical 3 over 2 comma negative 1/2, which is exactly the coordinate for quadrant 1, but with negatives. So we could say then the cosine of 210 can be represented as negative cos 30. The sine of 210 could be represented as negative sine 30, and so on. Okay, so that's where these reference angles are coming from. I'm using them to obtain answers in the other quadrants that would be equal. So this coordinate would be negative radical 2 over 2 comma negative radical 2 over 2. This one would just be negative 1/2 comma negative radical 3 over 2. We already have 0, negative 1. At 300, it would be the same as 60. So it's just, you're going over positive first and then negative. So I'd say the cosine of 300 would be the same as positive cosine 60. 315 would be radical 2 over 2, negative radical 2 over 2, and 330 would be the same as a 30-degree angle in quadrant 1. So it's radical 3 over 2, but it's negative 1/2. So we could say the sine of 330 is negative sine 30. So now if we go back, that's why we're able to, in the end here, come up with these answers. Positive sine 30, negative cos 30, and negative tan 30. For B, different directions. Express sine 250 and the others in terms of a function value of an acute angle. So function value of an acute angle, when you see those words, function value of an acute angle. That means you're going to come up with plus or minus, function name, so it could be sine, cosine, tan, cosecant, and then you're going to put the reference angle. Okay, so you'll see what we're going to do here. So sine 250, cos 250, tan 250. The quadrant is, so 250 in standard position. Here's 250 for theta. The reference angle is right here. To find that reference angle, I'm going to do 250 minus 180. Never am I using 270. So I think I get 70. So I'm in quadrant 3. The reference angle is 70, and the signs all change depending. So sine, sine, sine. In quadrant 3, sine is negative, cosine's negative, but tan's positive. So the sine of 250 is really equal to negative sine 70. And that is doing function value of an acute angle. Okay? Plus or minus, function name is sine, reference angle 70. Cos of 250 plus or minus, it was negative. Function name is cosine, 70 degrees is the reference angle. Tan of 250, positive. Function name is tan, reference angle. If you put those in your calculator, the tan of 250 is the same as the tan of 70. So if I do the tan of 250, it is the same as the tan of 70. If I do the cosine of 250, it's the same as negative cosine 70. Because they're going over to the same spot if you were to plot them as if they were points. Okay, next page. All right, a couple of problems here. So now we're going to be looking for theta. If tan theta is this negative, find to the nearest degree two positive values of theta that are less than 360. Okay, so if we just take a gander at our picture that we finished here, you should notice that the sine of 60 is identical answer to the sine of 120. They're both radical 3 over 2. So there can be two answers that have the same solutions. Sine of 150 is the same as sine of 30. Cosine of 30 is the same as cos of 330. They're both radical 3 over 2. So what we're going to set up here is a QRS. Okay? So tan theta is negative. You have to think of where is tan negative. So tan is negative in quadrants 4 and 2. So there's where my two angles are going to come from. Two positive values. The reference angle, to find that, I have to do second tan. Now, I am not interested in the negative, so I'm going to do always, to find the reference angle, it's positive. I'm going to do second tan of 0.7424. So second tan of 0.7424. Okay, and I'm going to do this, it says to the nearest degree, so I'm going to take this as 37 degrees. So my reference angle is 37 degrees. Now, my sine, really, I don't need that so much, but it's just to tell me that I need to look at where we are negative in quadrants 2 and 4. So now, to find the value of theta, what I am looking for, okay, is an angle in quadrant 2. So this is what I'm looking for now. I now need theta. I have the reference angle. I know this value now is 37. So I'm kind of working backwards. I'm not asking you for the reference angle. I'm asking you for the value of theta. So now I can take and find theta by doing 180 minus 37. So theta is 143 degrees. That's one of the values. And then if I take and I do quadrant 4, and I set up an angle in standard position in quadrant 4, there's theta. The reference angle, we know, is 37 degrees. It's always positive acute off the x-axis. So to find theta, now I'm going to do 360 minus 37. So theta is equal to 323 degrees. So if you punch in your calculator the tan of 143 and the tan of 323, they're very close to negative 0.7424. All right, next one. Given cosine of theta equals negative. Okay, so now on this one, I'm going to set up the same thing. So QRS. I'm looking for where is cosine negative. Cosine is negative in quadrants 2 and 3. So now I'm going to be in quadrants 2 and 3. To find that reference angle, I'm going to do second cosine of positive 0.6502. I want to keep these acute, and doing a positive, ignoring the negative will always give me a positive acute reference angle. So second cosine of 0.6502 is about 49. This one says to the nearest minute, so I'm going to go like 49.4433. Okay, so now I'm going to set up my diagram in quadrant 2 and draw my angle that I'm looking for. That's what I'm looking for. Here's the reference angle that I know is about 49 degrees. So I'm going to figure out theta, again, by taking 180 minus that 49.4433. And I'm going to DMS it. And when I do that, so I have it already in the display. I'm just going to keep it here. So I'm going to go to second apps, choice 4. And I get 49.2635 about. So it's 49. Oh, I'm sorry. It is, it's 130. I thought, maybe I looked at that wrong. Okay, so I have to do 180 minus that. I'm sorry, I messed that up. That puts me back to my, I should have just done 180 minus 49.44331729. And now I want to go to second apps. Sorry about that. Choice 4. So I get 130.33. Okay, so I get 130 degrees, 33 minutes, and it was 24 seconds. That's all I need of the seconds. And since that's 24, this rounds down to 130.33. Two positive values of theta, that's 1. Now let's go to quadrant 3 and set up our diagram in quadrant 3. So here's the angle in standard position that I'm looking for. There's theta. My reference angle is right in here. And that reference angle is, again, the 49, about. So now theta is going to be, if you think about it, 180 plus that 49. If you look at the picture, it makes sense. So 49.4433. All right, I don't have that back in my calculator anymore, so I'm going to do 180 plus the 49.4433. And then I'm going to go to the second apse. So I should have done that the first time too. And I get 229, 26, 35. So 229, 26, 35. So that's going to round up because 35 is greater than 29. So 229 degrees and 27 minutes. So those are the two answers. If you plug those into your calculator, cosine of those would equal that. All right, 3 and 4. Given sine theta equals 0. Oh, no. Okay. All right. Find all values of theta between 0 and 360. Okay, so you should notice 0. If it says 0 or -1 or +1, those are quadrantals, which means they are on the axes. So I'm looking at my unit circle then. 1, 0, 0, 1, -1, 0, and 0, -1. So I'm looking for where is the y-coordinate. I'm on the unit circle. Where's the y-coordinate? 0. So I see that the y-coordinate is 0 right here and right here. So those are my answers. What are the degree values there? Well, that's 0 and that's 180. So my answers are 180 and 0. If you take and do a little check, the sine of 180 says 0. The sine of 0 says 0. If you do the sine of 90, it says 1. No. If you do the sine of 270, that says -1. No. Next one, cosine theta equals -1. So again, that's a quadrantal. 0, 1, -1, that's a quadrantal. So again, I'm looking at that unit circle. Now I'm looking at where is the x-coordinate, -1. And I believe that I see the x-coordinate is -1 right at 180. So this, again, is 180 degrees, so my answer, I believe, is 180. If you're looking for theta, theta equals 180. Theta equals 180 and 0. So I'm trying to plug in there. So if I check the cosine of 180, my calculator will say -1. If I check the cosine of 270, my calculator is going to say 0. No. Any of the rest of them, the same problem. Okay. Next page, I'm going to quickly go through a -1 with you, and we'll be done. Okay, so for 150, I am going to draw that in. Oops, wrong way. I need to go negative. So here's -150. There's -150. So my reference angle is right here. My reference angle is 30. I'm in quadrant 3. And my sign is negative, negative, and positive for tan. Negative for sine and cosine, though. So to find the exact value of this, sine of -150 is equal to, remember, we do plus or minus, function name, reference angle. So I'm going to do minus sine 30, which I know is 1/2, so this answer is -1/2. The next one would be negative cos 30, which is negative radical 3/2. You can check it with the diagram also. And the tan of 150 is positive tan 30. We're in quadrant 3, so it's positive, which is radical 3/3. The next one, negative 250. So if I draw negative 250, I believe that that puts me right here. There is negative 250. My reference angle is right here. So to find that reference angle, I'm going to do 250 minus 180. And 250 minus 180 is 70. I'm in quadrant 2, so the signs will depend. So it's positive for sine, negative for cosine, and negative for tan. So sine of negative 250 is equal to positive sine 70, and that's all they want. Cosine of negative 250 is negative cosine 70. I wrote it as a function of a positive acute angle. That's what this is all about. Okay? Tan of negative 250 would be negative tan 70. And if you plug tan negative 250 into your calculator and negative tan 70, they would be the same. All right, that's it.